All right, so we're going to look at 5-4 today, which as you can see has a lot more formulas. So excited. So let's start with, we've got double angle formulas and half angle formulas, and then we have power reducing formulas. So the double angle formulas, right here, we have 3 of them. One of them terrific. Let's see if I can get it to where I want it to be. Hang on. Really? Did it stop? Those are double stars. Note that the sign of 2u does not equal, you can't take this 2 out in front. You can't take the sign of the single angle and just multiply it by 2. It doesn't work that way. So instead, if I want to find the sign of a double angle, is what you'll hear me call that. So my u would be 50 degrees, let's say in this case, times 2, I'd be trying to find the sign of 100. I would have to take the sine of 2 times the sine of 50 times the cosine of 50. And then I would end up with my sine for 100. That's all it's saying. And by no means is this the only possibility that I can replace the sine of 2u for. Why are we learning all these formulas? You're probably tired of them at this point, right? So, and you're going to be tired of my reason for this as well. So if I were you, I would put the following reason up here. All of these formulas, everything that we've been looking at, and then you'll see most specifically we're going to start to get into the meat of things with this particular section with substituting and manipulating equations and solving equations, bless you, today. So all of these, including what I'm showing you today, these are very helpful or useful in calc, meaning calculus. I know you're tired of hearing that. But what's the name of this course? Pre-calculus, meaning it's giving you all the foundation that you need for your calculus class. So if you don't take this stuff seriously and memorize and learn these things, and I'm not big on memorization, but I can tell you that the better calculus student knows all of these and understands them. And so the purpose today is to not only know the formulas, but understand how to use them. And the more practice you get at these, the better you become. So as you're going through your Math Excel homework, even though you might get a question correct, you might still feel fuzzy on that concept after you're done with it. You can always hit similar example and do another one. Hit another similar example, do another one. You can always keep your highest score, but I would do enough of these until you feel comfortable with them. And if you have questions, you've got to come ask. You can't wait to ask all your questions. We have a test next Thursday. So, your other ones that we're going to work with today would be the tangent of a double angle and the cosine of a double angle. Again, these are not our only choices. These are just the choices that are the most popular used, the most useful. We're going to do some problems today that we're going to get some values, for instance, for the cosine of a double angle that are not one of these 3. The cosine just happens to have 3 because it so happens to have 3 of the most useful equivalencies that we tend to swap out for things in calculus. So let's go ahead and look at an example. So we're going to look at example 1. We're going to actually prove our double angle. And don't we love that word prove? Come on now. So prove means I'm going to make one side, I'm just going to work on one side of the equation, make the other side look like the other one. So my suggestion would be that you always work on the left side and make it look like the right side. So we're going to start with the sine of 2x, and we're going to make it look like 2 sine of x cosine of x. So sine of 2x, and in fact, let me get my pen a little thicker. So sine of 2x equals I want to make it look like 2 sine of x cosine of x, so I have to do something with the sine of 2x in order to get myself there. So here's one thing that you may not have thought of doing. Yes?
Can that 2 sine of x cosine of x be rewritten as 2 sine cosine x?
No. He wants to know, right. He wants to know, can I just put the sine and the cosine together of x? It's saying that I'm taking 2 times the sine of that unknown angle times the cosine of that unknown angle. And we can't, every sine and cosine has to have an angle attached to it.
Okay.
So never is there a trig function that is sine cosine x. Does that make sense?
I thought there was in the previous chapter.
Mm-mm. Not that I can think of. You look for it and tell me if you see it.
Okay.
But we can't do that. So we're going to tell me if this is an equivalent substitution. Is the sine of 2x equal to the sine of x plus x? Are those equal? Does x plus x equal 2x? And now what can I substitute for here? Use your prior knowledge. Isn't this a sum of sine? Doesn't this come from 5-1? Right? And the pattern is sine, cosine, cosine, sine, right? And does the middle sign here change or stay the same? It stays the same. So that's what we're going to substitute for. So we've got equals. Awesome. Okay. So now we're back. All right. I love technology, don't you? So let's use the pattern. Oh, terrific. There we go. Sine of x. Cosine. Oh, my writing is, this is how I got in trouble in the first place. Sine of x cosine of x plus cosine of x sine of x. Would you agree that that is an equivalent substitution?
Yes.
Then the other thing that I want to do, and normally you wouldn't have to do this, but this term right here and this term right here are identical terms. Would you agree that I can switch these two around and make this read sine of x cosine of x? So let's go ahead and write that just for your note purposes. So we have sine of x cosine of x plus sine of x cosine of x. If I have one of these and I add one of those, how many of these do I have? 2 of those, and aren't those sine of x cosine of x's? So when I combine like terms, because they are 2 like terms, I have 2 cosine of x. Sorry. 2, really doesn't matter, but I want it to look like the original. 2 sine of x cosine of x. Have I proven that the left side equals the right side? I have proven that sine of 2x is indeed equal to 2 times the sine of x cosine of x. Questions about that? Yes?
Couldn't you just use one of the formulas from the top?
Because we're proving that formula. We're proving that formula. So when you're proving that formula, you can't use it. So otherwise it would have just been like a one-stepper, right? And so the difference is in example 2, we're now solving. So does anybody else have a question before we move on? So there's a difference between proving and solving.
So you got the sine of x, cosine of x, plus cosine of x, sine of x from 5-3.
5-1. The 5-1 formulas, the sum and difference. I'm sorry.
Yeah,
Yes, you're right. 5-3. You are right. Yeah, you're right. Sorry. My bad.
I got it.
All right, so anybody else have questions? You're good with that?
Because that's how you got the second cosine one.
What do you mean the second cosine? You mean this one here or this one
I
here?
mean, like, yeah, I have 2 cosines, but originally there was one. Like, the original problem.
In the original problem here, I started with this,
Yeah.
and I replaced it with this, because that's an equivalent substitution.
That's
And then,
the first part though, right?
right, then this right here, because I'm just working the left side of this equation because I'm proving it.
Okay. Oh,
So-
but the sign x plus x equals the
Yes,
what?
this right here equals this whole line here
Oh,
by
okay.
using that sum
Just substitute.
formula. I substituted again there. And I didn't have to do the second step here, but I chose to substitute this here with sine of x, cosine of x, so you could see visually that these two are identical, and I have two of them. And so you could have gone directly from here to this statement, but I want to be very clear that that's why we have two of them. All right? Anything else? Any issues with that? I had a question in one of my previous classes, Mrs. Murray, how am I supposed to know this? Well, you didn't until today, right? But with every life experience comes knowledge, doesn't it? So you just gain knowledge today. So there's a skill that you can go, oh, I can exchange 2x with x plus x. So note to self, right? All right, so then let's look at example 2. Now we're actually solving, emphasis on the word solving, this equation. And we're going to use the double angle identity in order to do so. Now when we solve an equation, I can take this equation here and I can put it into my graphing calculator in my y equals button, can't I? But in order to use my y equals button, what has to occur? One side has to be equal to 0. So when I graph this in my calculator, I have to either subtract the sine of 2x or subtract the cosine of x to make one side equal to 0 before I can even plug it in there. And then when I graph it, won't it be some sort of curve that looks like this? If you think of sine and cosine curves. Where is the solution to that curve? Why are we letting one side equal 0? To find the x, because isn't the solution where the graph crosses the x-axis? And isn't y the value on the x-axis? So when they ask you to solve, we're trying to find what value of x here will create the sine of double the angle equals the cosine of that single angle. What value of x will that occur? Well, if you think about it logically, it seems like a logical answer. What angle value has identical values for sine and cosine? 45 and 45, but oddly enough, the answer is not that. You'll see what it is in just a minute. Yes.
Why would you say 45 would be the answer? Why would someone think that?
Because what cosine ratio equals what sine ratio? And isn't it always cosine and sine of 45-degree angles is radical 2 over 2?
Yeah, you're right there, so you know that they're different.
Well, x, yes. So x would have to, what we're saying is x would have to be 45, which means that one would be 90 and one would be 45.
Oh,
But that's not true, is it? Because then if you let x equal 45, well, wait a minute, that's now 90. Yeah, so it seems like that would be reasonable, but doesn't work out that way. So how are we going to solve it now, since that logic doesn't work? So I would start off first by looking above I want to either make everything sine and cosine, or I want to get rid of this double angle, because I can't really solve when I have this 2x in there. It makes it difficult to solve. So look above. Do we have a substitution for the sine of 2x? Because I don't have any substitution for cosine of x. The only thing I can substitute for cosine of x is 1 over secant, right? And that's just going to make things more complicated. So what's my substitution for sine of 2x? Okay, so I'm going to sub for this what we have above, which is 2 sine of x, and I'm using x and not u because I have an x in my original problem, cosine of x equals cosine of x. So that's one substitution.
You can divide
Okay, a lot of you will think I can divide by what?
cosine.
Cosine of x. You can never divide by variable. Because if you divide by cosine of x, which seems reasonable, you're going to get 2 sine of x is equal to 1, and you're going to miss 2 of your answers. Because anytime, think about it this way. If I have x squared minus 2x equals 0, well, let's just have x squared minus 2x, or x squared equals 2x, right?
Okay.
If you divide by x, you end up with x equaling 2. Aren't you missing an answer when you divide by x of 0?
Okay.
Right? So we cannot divide by the cosine of x. So instead, first thing I want to do is make sure that I have 0 on one side. So how do I do that? I would be subtracting the cosine of x. from both sides. So I end up with 2 sine of x cosine of x. These are not like terms. Right here, these are not like terms. Minus cosine of x equals 0. So if I cannot divide by cosine of x, what can I do? Go back to algebra. When we moved everything over to one side of the equal sign in algebra, what did we do to try to solve? Factored. Can't we factor here? Do these have anything in common? They both have a cosine, right? So they both have this cosine of x here. So I'm going to take a cosine of x out in front of parentheses, and I'm going to write what's left over. Essentially, I'm going to divide each term here by the cosine of x. So if I divide this term by the cosine of x, the cosines cancel, and what are you left with? 2 sine of x. And then when I divide cosine of x by cosine of x, what do I get? 1, but it's a negative 1 because of this negative in front, so I have a minus 1. Again, go back to your algebra. If this is one factor, cosine of x, this is your second factor. If I've got 2 things that are being multiplied to give me 0, for a product to be 0, one of those 2 factors has to have a value of 0. So go back to your algebra again, if I factored and I had a problem where I had x plus 2 times x minus 4 equals 0, how would you solve for x? Set each factor equal to 0. So we're going to do the same thing here. We're going to set this factor, the cosine of x, equal to 0. And we're going to set this factor here, 2 sine of x minus 1 equal to 0. My goal is not to get x by itself. The x is attached to the trig function. You cannot separate the x from the cosine. It is not cosine times x. So your goal is to solve and get the trig function by itself. Isn't this trig function already by itself? And so the question is, what angle value of x gives you a cosine ratio of 0? Now, think about your unit circle. There's only so many ratios that are on the unit circle. There's 1/2, radical 3 over 2, rad 2 over 2. None of those are 0. And those all apply to 30, 60, and 45 degree angles, correct? Where on the unit circle do you see a 0? If it's not at those angles. There are zeros on the unit circle. Where do they occur? The north, south, east, west points, right? So you need to think to yourself, okay, let me look at my coordinate grid. Here is 0, here is pi over 2, here is pi, and here is 3 pi over 2. What are my ordered pairs at 0? 1, 0, and then this one, 0, 1, and this one, negative 1, 0, and this one, 0, negative 1. So, what value, make that go away, x or y is the cosine on those ordered pairs? The x. Where on those 4 ordered pairs, which ordered pairs have 0 as their x value? So this one right here, oh, that's red. I don't want red, I want black. This one right there, and this one right there, which belongs to those 2, correct? So my answer for x, what is the cosine of pi over 2? 0. What is the cosine of 3 pi over 2? 0. We just found 2 answers. So up here, I'm going to use blue. X is, I'm going to use blue. Let's see if I can erase that now. Yay. X is equal to, one answer is pi over 2, and another answer is 3 pi over 2. So if we had originally divided by cosine of x, we would have missed those 2 answers. But those aren't our only 2 answers, we have more. So then we need to solve this second function here. How do I get the sine of x by itself? Add 1. So I've got 2 sine of x equals 1, then what? Divide by 2. Sine of x is equal to 1/2. So what do I do when I don't have 0 or, in this case, if you have 0 or -1 or 1, you're doing something like this. So anytime you have 0, 1, or -1, you're looking at the ordered pairs at the north, south, east, west axis points. But if you have a ratio like 1/2, radical 3 over 2, radical 2 over 2, and you have to recognize the unrationalized versions of those ratios as well. 1 over rad 2 and 1 over rad 3. If you have any of those, they belong to those special right triangles, true? They belong to 36 and 90 degree triangles. I have to pay attention to my sign. If I want to find out, the question is saying what value of x is the sign positive 1/2. So the question begs, what quadrant is sign positive? So we've got all students take calculus. Where is sign positive? Quadrant 1 and quadrant 2. So what that means is I have 2 reference angles. I have one here in quadrant 1 and one here in quadrant 2. So this is bringing in more prior knowledge. So this is my x and this is my x. And my ratio, based upon what they gave me here, since my ratio is 1/2, sine is opposite over hypotenuse. So opposite x is 1, my hypotenuse is 2. Opposite x is 1, my hypotenuse is 2. I don't have to know that the other side is rad 3, because what I'm interested in is what is x? What degree? Can you see that up there? Kind of. If x is across from 1, what angle measure is that? Everybody. You should know it's 30 degrees, right? But all of our answers for these have to be in radians. So I need the radian measure for an angle that is 30 degrees in quadrant 1 and 30 degrees in quadrant 2. So the quadrant 1's easy. What's the radian? That's going to be 30 degrees, right? What's the radian measure of that? So one of my answers is pi over 6. And then we have to get the value for this one in quadrant 2. So there's a couple ways, remember, that you can do that. You can either realize that, okay, this is 30 degrees here, that's 180 here, 180 minus 30 is 150. So then you can convert that 150 into radians by using pi over 180. You could do that. Or you can realize that, okay, this is pi, so this should be 6 pi over 6 minus 1 pi over 6. What does that give you? So 5 pi over 6 is our other answer. So here are your answers to example 2. So that was a little tougher. It brings in a lot of prior knowledge and a lot of prior algebra knowledge. Yay. Issues, problems, concerns? How do you feel about that? Make sense? You do. You need more practice with it. That's a very good observation. So if after doing your problems you feel like you're still a little fuzzy, again, hit that similar example. And, you know, this is your education. It's not just about completing homework and checking that off and being done. This is a much harder semester, so let's finish strong. All right, so then let's move to the power-reducing formulas. So there are 3 of them. And all the power-reducing formula means is that it's taking, notice that we have the sine squared of u, cosine squared of u, and tan squared of u. Where have we seen squared trig functions before? In the Pythagorean identities. So previously, if I asked you to give me an equivalent value to sine squared u, you could use one of the Pythagorean identities. Remember, sine squared plus cosine squared equals 1. And so we converted that, solved for sine squared, and got 1 minus cosine squared. That's an equivalent value to sine squared. But if I want to replace something, Jesse, if I want to replace something into an equation without an exponent, and that's what power reducing means. Oftentimes in calculus, I want to replace or substitute something that does not have an exponent for various reasons. I have to be able to have another way to do it. And so we have had other formulas that have been derived, and here is one of them. 1 minus the cosine of the double angle divided by 2. Cosine squared looks very similar. It's got 1 plus the cosine of the double angle. And then where do you think tangent squared came up with its ratio? Sine over the cosine. So they just took this and divided it by this. The 2's canceled out and we ended up with this. So tangents are usually easier to derive because we get them from our sines and cosines. So let's go ahead and prove an identity. We're not going to be proving one of the power reducing formulas. We're going to use those to prove that the left side of something equals the right side of something. So let's look at example 3. And if I'm proving, what side do we start on? The left or the right side? We're going to start on the left. And so we're going to use cosine to the 4th of x. Cosine to the 4th of x. Yay. All right. Whew. Massive relief. Thank you, Matthew. All right. So as I look at this, have we looked at anything to the 4th power before? Nothing, right? So I have nothing to substitute in for cosine to the 4th of x. And I need you to understand that this right here is equivalent, it really means, it's not that it's equivalent to, it really means cosine of x all to the 4th power. You will never see me write it that way. You will not be allowed to write it that way in Math Excel or on your test. But I need you to understand that cosine to the 4th of x really means cosine of x times cosine of x times cosine of x times cosine of x. But we always write our exponent for our trig functions in between the trig name and the angle itself. And you need to make sure that it looks like an exponent and that it's not a coefficient. So if that is cosine x to the 4th, would you agree that that's a perfect square? Anything to the 4th power is a perfect square. Isn't sine to the 4th x then a perfect square? Isn't this the difference of two perfect squares? So since I have nothing to substitute these in for, I'm going to go back and rely on factoring. We use factoring for a lot of stuff. So can't I factor this as the difference of two perfect squares? Paused it again. No, I didn't. Good Lord. So then we have a plus and a minus. What is the square root of cosine to the 4th x? If this were x to the 4th, what's the square root of that? What's the square root of x to the 4th? X squared. So what's the square root of cosine to the 4th x? Cosine squared. And then plus sine squared of x, cosine squared of x minus sine squared of x. Now, let's think. We could substitute in things for the cosine squareds and sine squareds, but let's make things as simple as possible. What does this equal? You came up with that awfully quickly. Say it again. 1. Where did we come up with the fact that that's 1? It's a Pythagorean identity. Don't forget about those. So we are going to replace that with 1. And so then I have times cosine squared of x minus sine squared of x. Now that's not a Pythagorean identity, right? So instead, I propose that we replace it with, I want a better color. Orange will be good. So what can I replace that with? Remember what we're trying to prove? What are we trying to prove? Always go back to what you're trying to prove. I'm trying to get this right side to be equal to the cosine of the double angle. Is this one of the formulas for the cosine of the double angle? It's one of our 3 choices, isn't it? So I can completely swap this out with the cosine of 2x, can't I? So that's what we're going to do. So equals, this is the, oops, I don't want that color. This one is the cosine of 2x, and it's times 1. So now when I multiply those together, what do I get? Cosine of 2x. So I have proven that the cosine to the 4th of x minus the sine to the fourth of x is equal to the cosine of 2x. So technically, we have yet another formula that we could use here as a double angle formula for cosine. I'm probably not going to use that, but as I said earlier, those ones above are not the only ones that are out there. They're just the most popular ones, the most useful ones. All right, so any questions on that one? We're going to do one last one today. We're going to save number 5 for tomorrow. All right, so let's look at example 4. Example 4, you're not going to have enough room on here, and so I'm probably going to have to go to an extra piece of paper. And you're going to use the back of it. And when you go to the back, please use only the bottom quarter of the back, because we're going to have to need a lot of room on this to add some extra problems that we're going to do tomorrow. So bear that in mind. So this one, it says reducing a power of 4. We're going to rewrite the cosine of the fourth of x with no power greater than 1. No power greater than 1. What that means is you are to get rid of all exponents. So the exponents to the fourth power. So we're going to use substitution to do that. So I'm going to take the cosine to the fourth of x, and I'm going to start substituting. It's an expression. So I have nothing to the fourth that I can substitute in for that. And when I do substitute in for that, I'm trying to substitute in things that are going to not create powers, or at least reduce the power of the fourth to a smaller power, and then I can keep reducing to a smaller power. Is there any way, what do I have right now that I could substitute in for? I can substitute in for cosine squared, right? Well, how do I make cosine to the fourth look like something with cosine squared? Well, you can do cosine squared times cosine squared, or I do want you to realize that I can write this as a power to a power. Isn't that the same as cosine to the fourth of x? Power to power. Or you can write it cosine squared times cosine squared. So I still haven't gotten rid of my power, but can I replace cosine squared with something that will get rid of the power? I have two options. I have my Pythagorean identity, which would be 1 minus sine squared. Does that reduce a power? No. Or I have this power reducing formula above of 1 plus the cosine of the double angle over 2. Right? So the smartest thing would be to substitute in that for the power reducing formula. So that's what we're going to do. It's very hard to write and not hit that stop button. You just keep me on track. That'll be really good. All right, so if I multiply cosine of 2x times cosine of 2x, only the cosine gets squared. You do not square the 2x part, okay? So it only becomes plus cosine squared of the 2x, all over what? 4. Well, we still now we have an exponent again, right? But we have a smaller exponent. Went from a power of 4 to now a power of 2. So if I were you, I would collect like terms. So let's just start there. What would be like terms on here in the numerator? This is a like term, and this is a like term. If I have one cosine of 2x and I add another cosine of 2x, how many of them do I have? 2 of them. So we've got equals 1 plus 2 cosine of 2x's. The 2x doesn't change on that either. Plus cosine squared of 2x, all over 4. So at this point, I'm kind of running out of room. So I'm going to choose to move to a blank paper. So I'm going to continue on another sheet of paper. All right, so this is, go away, example 4, continued. So my writing gets really bad up there. All right. So you're going to have to jockey back and forth because I'm not going to be able to show my paper back and forth up there. So look at the last step that we did. I want to take that 4 in the denominator, and I want to divide every term by 4. So look at your numerator. The first term we have in the numerator is 1. What's 1 divided by 4?
Question.
Yes. No, I can't go back. You're going to have to wait. What's wrong? If you need me to slow down, you got to tell me earlier.
2x times 2 is 2x. Why still is 2? Since I changed to 4.
Because if you take the cosine of x times the cosine of x, wouldn't that be cosine squared of x?
It is 2x.
It doesn't matter. Answer my question. If I take the cosine of x times the cosine of x, isn't it cosine squared of x? We don't do anything with the x. The x did not get changed. We didn't do x times x, so we didn't do x plus x, right? So if you're going to do cosine of 2x times cosine of 2x, the only thing that gets squared is the trig function itself, the cosine. The 2x doesn't change, so it doesn't become 4x. I'll show you how it becomes 4x here in a minute. You'll see how that might happen. All right, so the first term is 1, right? So we get equals 1 divided by the 4. The second term is 2 cosine of 2x, right? If I want to divide that by 4, what are the two things that get divided? The 2, the coefficient of 2 over the 4, what's 2/4? So the next term becomes 1/2 cosine of the 2x. You okay with that? Okay, so far so good. And then the last term is the cosine squared of 2x. Currently, what's the coefficient of cosine squared 2x? 1. So what's 1 divided by 4? 1/4. So then our last term is plus 1/4 cosine squared. And then I'm going to write my 2x in a different color for a very specific reason. You'll see why in a minute. Isn't my 2x my entire angle measurement? Okay, so the only thing that we have left to get rid of is that power, that exponent of 2. So can I substitute in for cosine squared? Don't we have a power reducing formula for cosine squared? Isn't the power reducing formula, come back here, for cosine squared, for right here, isn't that power reducing formula equal to cosine squared of x, plain x, not a 2x, so that's why I'm emphasizing this, is equal to 1 plus the cosine of 2x over 2. Right. So that's my power reducing formula, but note that my angle here is 2x, not x. This is a power reducing formula for cosine squared of x, not of 2x, but we can fix it. So if all they did was they took this x here and they put it in there. So if this x here was put in there, what am I going to put in for x here? What's my x? 2x. So this 2x is going to go here in place of that x, that whole 2x. So here's how it looks when we replace it. So equals 1/4 plus 1/2 cosine of 2x plus, and then I'm going to put this 1/4 here, and I'm replacing all of this, the cosine squared of 2x, so I'm going to use a big parentheses, and I'm replacing it with 1 plus the cosine of 2, and instead of x, what do I put in there? The 2x. So this becomes here, I kind of ran out of room, my 2x. So that's 1 plus the cosine of 2 times 2x all over 2. I'm going slowly on purpose. I don't want to lose anybody. Now what can I do? So would you be okay if I multiplied these two together at the same time that I multiply 1 to the numerator and 4 to the denominator? Because I have a fraction times a fraction. Don't you multiply the numerator to the numerator and the denominator to the denominator? Right? So let's go ahead and rewrite what doesn't change. 1/4 plus 1/2 the cosine of 2x plus, now I'm going to take my 1 and multiply it by all of this. So 1 times all of this doesn't change, but what does the 2 times 2x become? 4x. So I get in my numerator 1 plus the cosine of 4x all over, so the 4 is the big part that changed, and then what's the 4 times 2? 4 times 2? 8. Well, that's a terrible 8. How about 8 again? Almost done. We have 2 more steps. Don't I still have a fraction in my problem? A term that's a fraction? We have to get rid of that. So in order to get rid of that, can't I take each of these terms here and divide them by 8? So here we go. Equals 1/4 plus 1/2 cosine of 2x plus, what is 1 divided by 8? 1/8. And then plus, what is cosine? What's the coefficient of cosine of 4x? 1. So it's 1 divided by 8. So my coefficient is 1/8 times the cosine of 4x. We're not done. Don't pack up. Then, do we have any like terms? Don't we have 1/4 and 1/8? What's the LCD? 8. So I need to convert this denominator here to something over 8. So I'm going to multiply top and bottom by 2. What does that give me here? 2/8 plus 1/8. Oh, last step. That gives us 3/8 plus 1/2 the cosine of 2x plus 1/8 the cosine of 4x. Glory, hallelujah. That was a hairy problem. Now, no, well, there technically is. Your book wants you to factor out that least common denominator of 1/8, but we're not going to. We're not going to.
That's good.
We're not doing
So today we're going to look at the half angle formulas, and as you can see, we have 3 of those. Just looking for my stylus. And here's our 3. I've got the sine of my angle divided by 2, which is your half angle, cosine, and tangent. It's really important that you realize, notice that the difference between sine and cosine, and then the tangent one, sine and cosine both have the square root, and typically when we take the square root of both sides, we have to do a plus or a minus, whereas tangent, we didn't have that issue. So with sine and cosine, and I wrote this note to you down here, with sine and cosine, you have to determine is the answer positive or negative. And to determine whether the answer is the positive or the negative choice depends upon what quadrant this half angle is in. If the half angle for sine, if the half angle is in quadrant 1 or 2, you're going to have a positive answer, because that's where sine is positive. If your half angle is in quadrants 3 and 4, you're going to have the negative answer. Whereas when you do the cosine of a half angle, if your angle is in quadrants 1 or 4, you're going to have the positive answer, and then 2 and 3 would give you the negative answer. So that's the only thing that you have to watch. So we're going to solve an equation using our half angle identities. And we've got sine squared of x equals 2 times the sine squared of a half angle. So here's the issue. This right here, so we're going to not include the 2, this right here really means sine of x divided by 2, all of that would be squared. So remember that that's what that sine squared means, that the tangent or the tangent, the trig function and its degree, that's what it is raised to the power. And so the reason why I want you to realize that is because I'm going to substitute in for this value here using our half angle identity here for sine. So I'm going to take all of this and I'm going to plug it into the parentheses here and then square it, keeping in mind that the 2 is going to be out in front. So I want to get rid of that half angle, just like if I had a double angle in there, I'd want to get rid of that. And then we'll kind of determine if we want to keep the sine squared or if we want to convert that. Because I would like all of my trig functions to be the same if possible. We'll see if that's possible. So let's start off with the right side first. So I've got equals 2 times, and then in parentheses, I'm going to square that. I'm going to substitute in the half angle formula that I have here, including the plus minus. So I have plus or minus the square root of 1 minus cosine of x, because my angle is named x, not u, all divided by 2. So what happens when I square a radical? The radical goes away. What happens when I square a negative? It becomes a positive. So isn't the plus minus kind of a moot point at this rate? And then my sine squared I have over here, sine squared of x. So let's go ahead and figure out what the right side looks like and then determine, do I want to substitute in for sine squared? So I have equals 2 times, and we're going to take away that radical and the plus minus, so I end up with 1 minus the cosine of x, that's a cosine, all divided by 2. So we've squared it. Then what happens to the 2's? Here and here, they cancel out. So this is really over 1, and that 2 cancels with that 2. So my right side, I really have 1 minus the cosine of x. So do I want to keep sine squared, or do I want to substitute it in for something? If I keep it, I can't, remember I'm solving, so I want one side equal to 0. If I keep it, I'm going to move everything over to that sine squared side. Can you factor that? Nope. So the sine squared is not going to do you any good. So so far I have 2 options to plug in for sine squared. So flip your paper over to the other side and look at your power reducing formulas above example 3 and 4. You have a choice of 1 minus the cosine of 2u over 2. What's going to happen if I replace sine squared with the power reducing formula? Wouldn't I have to substitute in for cosine of 2u? I'd have to do another substitution. Is there any other value I can substitute in for sine squared that we've used in the past? Yes, what? Way back in 5-1. Yeah, use your Pythagorean identity. Sine squared plus cosine squared equals 1. What does sine squared equal? 1 minus cosine squared. And doesn't that work with this? If I have 1 minus cosine squared over here and I have a cosine here, that's going to work. It's going to enable me to be able to factor. So let's go ahead and do that. So I'm losing my voice. So we are going to replace the left side with 1 minus cosine squared of x. And all we did was replace this with that. Then I want to get everything over to one side. I want my highest degree term to be positive. Which is my highest degree term here? The cosine squared. Is it positive? No, so I want to move everything over to the right. So I'm going to subtract a 1 from both sides, and I'm going to add a cosine squared of x to both sides. Bearing in mind that the cosine of x and the cosine squared of x are not like terms, so you cannot combine those. So I end up with these canceling on the left, and I have a 0 on the left equals. The 1's on the right cancel, and I want my cosine squared coming first, so cosine squared of x minus the cosine of x. Can that be factored? Yes,
Would it be a negative?
it is, right? So what do they have in common? They have a cosine of x in common. So I'm going to factor out a cosine of x out in front. And if I divide this by cosine of x, what do I have? Cosine of x. And if I divide this one by cosine of x, I get a minus 1. And I've had some kids ask me today, at this step right here, the step above this one, can I just set those equal to 0? How come I can't set those equal to 0? Well, you have this negative outside of parentheses. You can't set anything equal to 0 if you don't have factors, and factors are things that are multiplied. So now that I've factored it, I have 2 factors. Those I can set equal to 0 to solve. So I'm going to take the cosine of x and set it equal to 0, and I'm going to take the cosine of x minus 1 and set it equal to 0. My goal is to get the trig function on one side by itself. Don't I already have that here? Isn't this already solved for the trig function? Anytime I have 0, 1, or negative 1, I want to look at my north, south, east, west coordinate points because those are the ordered pairs that contain 0, 1, and negative 1. And this is asking you what angle value of x has a cosine that is 0 degrees. So if I look at my coordinate grid and I look at 0, pi over 2, pi, and 3 pi over 2. I want my ordered pairs at those points. My ordered pairs at 0 would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So is cosine the x value or the y value?
X.
Oops. So cosine's my x value. So which of the ordered pairs has an x value of 0? Yeah, so 3 pi over 2 and pi over 2. So those are 2 of my answers. So I know that x is going to equal pi over 2 and 3 pi over 2. So those are 2 of my answers. Then we have to solve the cosine of x minus 1 for cosine of x. So what do I have to do there? Just add 1. So cosine of x is equal to 1. Again, if this right here is 1, 0, or negative 1, I'm looking at the coordinate points. So I don't have to redraw this. I can just look at this again. Cosine, again, is the x value. Which ordered pair has an x value of 1? Yeah, so I've got, oh, let's put it in black. So this is the only one that has an ordered pair of an x value with 1. So that means that I have an additional answer here of 0. So these are my, and this time I only had 3 values for x. Now there was nothing in the original problem that said that they restricted the domain from 0 to 2 pi. Question 1. What? Because normally, so I'm going to answer that, if we're not restricted. If we are restricted, remember our restriction is a bracket at 0, but a parentheses at 2 pi, meaning we include 0 but not 2 pi. Because 0 and 2 pi are in the same place. Aren't we double counting that same place on the unit circle? And that's why. But if, and there's 1 or 2 questions on your Math Excel homework where they don't restrict the domain. So technically, if one of my answers here is pi over 2, every full revolution of pi over 2 is another answer. Every full revolution of 3 pi over 2, let's see if I can, so let's see if I can use that one. All right, so every full revolution of 3 pi over 2 is going to give me another answer. Every full revolution of 0 is going to give me another answer. So I have an infinite number of answers if my domain is not restricted. So if that's the case, how do I write that? So it's an excellent question. So let's just start off with, what if one of our answers, which it is pi over 2. So if that's one of my answers, I'm going to add to that a full revolution. What's a full revolution? 2 pi. But I could keep doing that over and over and over again. So I don't know how many full revolutions they want, but it's an infinite number. So I'm going to add 2. Let me get a different color. I'm going to add 2n pi. N represents the number of revolutions. Well, it's an infinite number. So if you wanted the first 5 revolutions in the domain, you would just keep multiplying and adding. And then our next answer choice is 3 pi over 2. And so to that, I would want to add another 2n pi. And then also with 0, my last answer choice, I would again want to add a 2n pi to that as well. So this right here would be your answer choice. This would be your answer if the domain is not restricted. And it'll be obvious on your homework when they want that answer. This answer here is when the domain is restricted to 0 with a bracket, comma, 2 pi with a parentheses. So it doesn't change how we solve the problem. It just changes how you write the answer. So you just tack on a 2n pi to every single answer choice. So if you go back to example 2, we had 4 answer choices. If you had an unrestricted domain, you would just add to each of those 4 answer choices 2n pi. It depends on what's being asked. So you have to look to see, and when you go to Math Excel, you'll see what your answer choices are. Sometimes they use the words unrestricted. Sometimes when you look at your answer choices, it's obvious that it's unrestricted because they're adding 2n pi to that. So it should be obvious. I'll make it very clear on my test. If I restrict the domain, I'll say that, on this interval, 0 to 2 pi. Or I won't just leave it blank like these ones are. I'll say the domain is unrestricted, to be fair, right? All right, so then I want to add some problems to this because I don't think that's enough problems for you to be able to understand your homework. So let me find my first. So my first problem, we're going to call this example 6. So for example 6, you will find the exact value of 5 pi over 12 using half angle identities. Looks like a kindergartner's writing that. Yay. So most of you are uncomfortable with what 5 pi over 12 means. So my suggestion would be, step 1 would be to convert 2 degrees. So we're going to take 5 pi over 12 and we're going to multiply it. What's the conversion factor? Yep, 180 over pi. And so that equals, the pi's cancel. How many times does 12 go into 180? We've done this a lot by now. 15 times. And what is 5 times 15? What?
7.
Higher? Less?
90.
Isn't it 75 degrees?
Because
You
you
guys
said
are,
I said
Right.
50.
well, I thought you said
And then you said
65.
100.
I thought she said 70. See, I'm old. I can't hear. Give me a break. What are you my age, Seth? You can do it on the right side. You might still run out of room when we do our second example, so you might need an extra sheet of paper. So wherever you can fit it. Some of you write really big, some of you write really tiny. All right, so really what I'm finding is that, oh, did I not put tangent in front of that? That's hilarious. So, yeah, so you need to add tangent in front of this. So we're finding the exact value of the tangent of 5 pi over 12. So sorry. So really what I'm finding is the tangent of 75 degrees. Now, we can find the tangent of 75 using a sum formula, right? We did that in 5-3. But they're specifically asking you to use a half angle identity. So here's what you got to do. Your second step is going to be always to double the angle measure in order to use the half angle identity. And the reason for that is, if you look at those half angle identities up there, you look at the tangent of u over 2. U over 2 has got to equal my 75 degrees. It says double the angle measure. That's geometry shorthand. Double the angle measure in order to use the half identity. So I need this 75 degrees to equal that u over 2. I have to find out what my u is that I'm going to put into that half angle identity. And so do you understand why I have to double my angle measure if I'm going to solve this equation here? So to solve for u, I'd have to multiply both sides by 2. So we're going to take our 75 degrees and we are going to multiply by 2. What does that give me? 150 degrees. That is going to equal u in the half angle identity. So then step 3, we are going to find the tangent of 150 degrees divided by 2. Now it matches a half angle, because that's tangent of u over 2. So if that's tangent of u over 2, I can set that equal to either one of my two tangent formulas. It really doesn't matter which one you use, the 1 minus cosine of u over sine of u, or the sine of u over 1 plus cosine of u. Doesn't matter which one. You can choose whichever one you want to. You make up your mind right now, and then your answer should end up to be exactly the same as my answer. So I'm going to go ahead and use the sine over 1 plus cosine just because I like all positives, but that doesn't mean that the sine of u and the cosine of u are automatically going to be positive ratios, because you got to pay attention to where your double angle is at. So over here, my half angle is in what quadrant? What's 75 degrees? That's in quadrant 1. So overall, I would expect my ratio value here to come out to be positive, because tangent's positive in quadrant 1. But over here, we're putting in 150. We're going to find the sine and cosine of 150 because we're finding the sine and cosine of u. Well, my u is 150. So what quadrant is 150 in? Quadrant 2. So that means that from here to here is 150 degrees. So what's my reference angle? So I'm looking at a 30-degree reference angle, and that's why we doubled our angle, because we can use the doubled angle to give us a special right triangle angle to find the answer to, which is nice. So then let's set up our ratios. I know across from 30 is 1, and in this case it's positive 1. Adjacent to 30 should be negative radical 3, and I know it's negative because there's an x negative in quadrant 2. And then my hypotenuse is 2. So I want to also find because I didn't write it up here. So let's write out our formula. I'm going to use sine of u over 1 plus cosine of u. So I want to know what my sine of u is in quadrant 2, because that's where my half angle is. That's where u is. I'm sorry, that's where u is, not my half angle. So I want the sine of u. So what's the sine using 30 degrees as my reference angle? What's my sine? Some old hippie. Opposite over hypotenuse, which is? Opposite is 1, hypotenuse is 2. So my sine is positive 1/2. Remember, sine is positive in quadrant 2. And then what is the cosine of u? Negative radical 3 over positive 2. So I have one positive and one negative. So we're going to go ahead and plug in. So I've got equals 1 plus. So I'm going to plug in. For sine, I'm going to put in 1/2. And for the cosine, I'm going to put in negative radical 3 over 2. And then we're just going to keep using our algebra to simplify. So I've got fractions and fractions. You want to make sure that you convert this entire denominator into one full fraction. So in order to do that, don't I want 1 right here to be something over 2? True or false?
True.
Okay, so I'm going to convert 1 to 2 over 2. So from there, it looks like 1/2 divided by. My numerator would be 2 minus the square root of 3. They're both over the same denominator now, so I can put it over 2. Are you okay with that? Right? And so now I can take the numerator and multiply it by the reciprocal of the denominator. So I'm going to move this up. Why won't it move up? Really? There, now it's moving up. It's crooked now, isn't it? Oh well, I'm not going to let it bother me. Alright, so I'm going to take the numerator, which is 1/2, and I'm multiplying it by the reciprocal of the denominator, which is 2 divided by 2 minus radical 3. So what happens?
The 2's cancel.
Oh, okay. I just was thinking I did something wrong here for a minute. Nope, I'm good. So the 2's cancel, and what are you left with? 1 over 2 minus radical 3. Probably Math Excel won't accept that. I don't even like that as an answer. We need to rationalize it.
Thank you.
So how are we going to rationalize that? Nope, you cannot multiply by rad 3 because you have a 2 minus in there.
2.
So you have to multiply by the conjugate, which is 2 plus radical 3. And you have to do that to both the numerator and the denominator. Was that Juan who said that? Well done. And so that equals 1 times the numerator is 2 plus the square root of 3 divided by. And then don't forget that this is the difference of 2 squares pattern. So it multiplies as a squared, which is 2 squared, minus rad 3 squared. So 2 squared is 4 minus rad 3 squared is 3. And isn't 4 minus 3 1? So doesn't this equal 2 plus the square root of 3? Is that going to be a positive answer or a negative answer? A positive answer. Now remember, our half angle was 75 degrees. What quadrant is our half angle in? The first quadrant. What's the sign of tangent in first quadrant? Positive. So that's a reasonable answer. All right, we're going to do one more. Any questions on that one before we do one more? One? About the sign? Okay. Would you agree that this answer is going to come out positive? And this is the answer to the tangent of 75 degrees, because it's the answer to the tangent of u over 2. Well, my u was 150 divided by 2 is 75. So the whole purpose of using that half angle identity was to actually find the tangent of 75 degrees. Right? 75 degrees is in quadrant 1. Isn't the sign of tangent positive in quadrant 1? Okay, and you can check this by taking your calculator and taking 2 plus the square root of 3 and finding its decimal equivalency, and then taking the tangent of 75 degrees and looking at its decimal equivalency. Of course, making sure that your calculator's mode is in degrees. They should be identical, and they will be. And so that's how you can kind of check your answer to see if you're right. All right, so one more. Bless you. And then this is going to be example 7. Goodness, I don't know what that was. Example 7. So we're going to do kind of a similar thing. We're going to find the exact value of the cosine of 11 pi over 12 using half angle identities. So this is no different process than what we did in the last problem. What should be my first step? Yeah, we're going to convert. So step 1, convert to degrees. So I'm going to take 11 pi divided by 12, and I'm going to multiply it by 180 divided by pi. Your pi's disappear, and 12 divides into 180 how many times? So 12 goes into 180 15 times. And remember the little trick that I've showed you? If you're multiplying anything to 11, take that anything, which in this case is 15, split it apart, and then multiply the 1 of the, or add the 1 and the 5 together, you get 6. So 11 times 15 is 165. Isn't that a fun trick? You're not quite so impressed by it. All right, so I have 165 degrees. What quadrant is 165 degrees in? Quadrant 2. We will. Absolutely, we will. So from here to here is my 165 degrees. So what's my reference angle? What's 180 minus 165? 15 degrees. So we can't use our traditional methods because I don't have a special right triangle with 15 degrees. But we do have to double our angle. So in order to use a half angle identity, we'll double the angle. That will double my reference angle. What's double 15? Ah, now I can use that. So that's the joy of using these half angle identities. So step 2, you are going to double the angle in order to use the half angle identity. So we're going to take 165 degrees and we are going to multiply that by 2. What does that give you? It is 300. I don't want that color. It is 330 degrees. And that is what is equal to u. So we found u. U over 2 is my 165. So this is u over 2. That's what we want. Okay. So step 3, we're going to apply that half angle identity, and since we're doing cosine, we've got cosine of my u is 330 divided by 2 equals. So our identity is plus or minus, that's a plus. So plus or minus 1 plus the cosine of u divided by 2. Right? All I have to know is the cosine of u. So u is 330 degrees. So I need to look at my coordinate grid. What quadrant is 330 in? Quadrant 4. So u is in quadrant 4. That means that my reference angle is what? So this is 30 degrees, whereas from here to here is the 330 degrees. So across from 30 should be a -1 because y is negative in quadrant 4. Adjacent should be a positive radical 3, and then 2 is your hypotenuse. So if I want cosine of u, what does that equal? What's cosine of u? What? Adjacent over hypotenuse, which is radical 3 over 2. That's all I need off of there. So now I'm ready to plug into my formula. So I have equals plus or minus the square root of 1 plus, I'm going to replace the cosine of u with radical 3 over 2, and all of that is divided by 2, bearing in mind that that goes all the way down to the denominator. So I have fractions and a fraction underneath a radical, no less, and I have a radical under a radical, so this is all fun games. So we're going to take it step by step. This equals plus or minus. I want to change my numerator here into 1 full fraction. So what should I convert 1 into? 2 over 2. And so that gives me plus or minus the square root of 2 plus the square root of 3 all over 2, and all of that is over what? 2. Then we have to deal with the fraction and the fraction. So this equals plus or minus the square root of, because it's still under square root, I'm going to take my numerator here and multiply it by the reciprocal of the denominator all underneath that radical, so it stays under the radical. So my numerator, which is 2 plus the square root of 3 divided by 2, I'm going to multiply that by the reciprocal of the denominator. What's the reciprocal of 2? 1/2. So the 2's don't actually disappear.
No, but isn't it 2 over 1?
2 over 1, the reciprocal is 1 over 2, right? So what I actually have here, can't I split up, I'm going to multiply this numerator to 1, which gives me 2 plus rad 3. And this denominator becomes 2 times 2 is 4. When you take the square root of a fraction, can't you take the square root of the numerator separately from the square root of the denominator? True or false? True. So I'm going to split that up. I'm going to take plus or minus the square root of the numerator, which multiplied, the numerator becomes 2 plus radical 3, because times that 1 it doesn't change. Whoops. 2 plus the square root of 3. All divided by the square root of, when you multiply 2 times 2, you get 4. Can I take the square root of the numerator? No. So that doesn't change. So plus or minus the square root of 2 plus the square root of 3. All divided by, what's the square root of 4? 2. Now, that's almost our answer. But you have to make a choice. Is it positive or negative? Look at where your half angle is. So let's go back up here to, look at, it's overlapping. Look at where our half angle is. Our half angle is in quadrant 2. What is the sign of cosine in quadrant 2? All students.
Negative.
It's negative. So because cosine, and so you want to write yourself the following note. So here, since cosine of u over 2, that's our half angle, is negative in quadrant 2, and that's because our half angle is in quadrant 2, you must choose the negative answer. So our final answer is negative square root of 2 plus the square root of 3 all over 2. So this is my final answer. And note that in Math Excel, you are going to be putting a radical underneath a radical. So be careful when you input that kind of an answer. All right, so any issues, problems, or concerns with that? Seth?
So you could do taking the square root separately.
When you have a fraction underneath a square root, and won't this turn out to be, if I multiply it to 1, I'll have 2 plus rad 3 all over 4. So I want to actually simplify that by taking the square root if at all possible. Well, when you have a fraction underneath there, you want to take the square root of the numerator separately from the square root of the denominator. I can separate them out. And so that's how I ended up having 2 in the denominator. Juan? The final answer sign is determined by the quadrant in which the half angle resides in. So we use the double angle to actually find the ratio value, but we use the half angle to determine the sign because that's really what we're looking for. Any other issues, concerns, questions? Okay.